This software agent acts in a scientific and virtual environment. The agent wants to solve tasks which require different skills. The communication of two agents who have a different skill set is restricted. In the same way, it is difficult for a single agent who possesses two different skills to connect both skills. Hello universe. This is Zahra M.M.A. Sadiq. I define a mathematical equation which connects the domain task with the reinforcement learning technique. All real numbers are elements of the domain set. The instances y are elements of the range set. Values of both sets are codependent. I assign a value of y to each function of x. The following factors influence the result of the agent's interaction. O designates the opportunity to find a suitable variable, item or word, and to receive a reward. Upsilon designates the utility of the agent's last action. Omega is the utility of the action proposed by the second skill of the agent. C is the degree of suitability of m-1 operators and n variables or terms. And S designates the structural deadline and the end of the statement. These factors influence the result of the agent's interaction. I calculate the next spread of the interaction values. My first state of the Markov decision process is the interaction function. I search for an action for this first state. If one agent processes multiple tasks, it can even accept or reject its own offer. The agent maximizes its expected reward and develops the policy. This policy is a neural net with scenario parameters corresponding to weights. In a multi-agent transfer learning setting, I prepare the reinforcement learning procedure by using one or two neural nets. I calculate the function referring to the source network in the framework of the policy function. I integrate two pools for weights from both source networks which the neural nets share into the procedure. I optimize and update the parameters to maximize the expected reward. I calculate two bidirectional policies with Bayesian learning. This algorithm solves tasks whose solution requires different skills. The algorithm integrates the equation which I use to calculate the domain knowledge into the reinforcement learning procedure. By using this technique, I reduce the number of agents of this multi-agent setting. Two agents pre-process the source and one agent solves the target. By using my deep reasoning creator algorithm, I process logic and reasoning tasks, math and reasoning tasks, and language and logic tasks. I also use this technique to write logical and mathematical proofs.